All right, so today we are going to start covering some information about polynomials and classifying them. Last time y'all were in class with me, y'all took a test. Those test grades will hopefully be in by Thursday morning, Thursday afternoon. I still have my B-Day kids that need to take the test, so hopefully we'll get those in soon, but they are not in yet. I have some of y'all's already graded and in my grade book, but not on Skyward yet, so I will get those in soon. For missing assignments, y'all need to start getting those turned in. I'm going to start counting stuff late. If you have a question about where to find a missing assignment, please email me. I will show you where to find it. I may even just send it to you in the email. But we got to start getting stuff turned in. If you're behind on Mathia, you need to get caught up. We're going to be doing more Mathia this unit, so the farther behind you are, the more zeros you have, and I'm just getting very, very, very tired of zeros in that grade book. So if you need help, let me know, and make sure y'all are watching these videos all the way through because that's how attendance is being taken. So if y'all have any questions, let me know, especially with the new plan book on Kedem that I'm using. If y'all have any questions, let me know, okay? And y'all can reach me through email or through Remind. I will probably get a Remind message before I will get an email. So whichever you prefer, but just try to get in touch with me as soon as possible. But we are going to start classifying some polynomials, and we will be able to identify and classify polynomials is our objective of this part of the notes. So the first thing we're going to go over is a few definitions. So a monomial, oh, you can't even see that that's an M. A monomial is a number or a product of numbers and variables with whole number exponents. And we have a few examples listed down here. So we're talking about 3x, x squared, y to the fifth z, and also x times y divided by 2. So they're whole number exponents. So, for example, this x has a 1, 2, 5, all of those. All right, and a polynomial, which is really what we are covering this unit, is a monomial or a sum or a difference of monomials. Each monomial in a polynomial is called a term. So some examples of some polynomials is 3x squared. So 3x squared is a term. And then 2 times 5x is a term plus 9x to the fourth. And this whole thing is a polynomial, but each little term is a monomial. And then 1/2 a to the fourth. And then if we were to come down here, so not polynomials. So an example of not polynomials is that 3 to the x power, it does not have a whole number exponent. And then with it being in absolute values down here, makes it not a polynomial. The square root here makes it not a polynomial, and the 0.5 power also makes it not a polynomial. And this, what I'm going to talk about last, this 8 divided by 5y squared. So that is not a polynomial either because it is not a sum or a difference. It is a division. All right, so the degree of the monomial is the sum of the exponents of the variables. So we're just talking about variables here. So for example, if we're looking at x to the fourth, that has a degree of 4. If we're looking at 12, though, we don't have any variables. We just have numbers. So we have 0. If you are looking down here at 4a squared plus or times b, so we're looking at 2 plus 1 is our exponent of those variables, giving us a degree of 3. Then out here we have x cubed times y to the fourth times z, and that'll give us a degree of 8. All right, then we got some more definitions down here, and the degree of, let's do of the polynomial. The degree of the polynomial is given by the term with the greatest degree. So a polynomial is written in standard form when its terms are written in descending order by degree. So that's starting at the highest degree and going all the way to the lowest degree. And there's even an example down here. So we're starting at 3, 2, 1, 0. In standard form, the degree of the first term indicates the degree of the polynomial, and the leading coefficient is the coefficient of the first term. So for example, the degree of this polynomial is going to be determined by this exponent up here, and the leading coefficient is that 5 that is in front of the first term. A polynomial can be classified by its number of terms. So a polynomial with 2 terms is called a binomial. And a polynomial with 3 terms is called a trinomial. And a polynomial with 4 or more terms is called a polynomial with x terms. And so like the x would be, if it was with those 4 terms, it'd be a polynomial with 4 terms. If it had 5 terms, it'd be a polynomial with 5 terms. So on this next slide, we have a little chart here about how we classify polynomials by degree. So if we're looking at just a number, it has 0 degrees, so it is a constant. If we are looking at like x minus 4, that variable, the degree on it is 1, which we can see here, and that is a linear. The highest degree in this one is 2, so it is 2, so it is a quadratic. If the highest degree is a 3, it is a cubic. If it is 4, it is quartic, and if it's 5, it is quintic, which we're going to classify some of these down here. So if we're looking at number 1, the highest degree in this problem is that 4. So whenever we are classifying it by degree, you could look up and see that this would be a quartic. And if you're looking at the number of terms, we have 2 terms, so we are looking at a binomial. And if you're confused about where I'm getting these words from, so if we're talking about degree, which is up here, our highest degree is that 4, so it is a quartic. And whenever we were talking about terms on the previous page, if it has 2 terms, it was called a binomial. So you're going to need to remember these for your test on this unit. You're going to have to be able to classify these by their degree and their number of terms. So if we're looking at number 2, our highest degree in there is 4, which would make it a quartic as well. But in this one, we have 3 terms, which makes it a trinomial. So I'm going to start letting y'all get some practice with these. So you're going to input your answer, and then I'm going to go over it. So when we're talking about this one, number 3, we are looking at a quadratic because we have that second degree, and then we have 2 terms, so we are then looking at a binomial. For number 4, our highest degree is 5, so we are looking at a quintic. And we have 1, 2, 3, 4 terms here, so we are looking at a polynomial. With 4 terms. Number 5, we are looking at a linear based off degree, and then a binomial. Based off terms. So we'll scroll up to the top and look at number 6. Our degree here is that quartic again. Or sorry, it is a quadratic. Sorry, excuse me. Hopefully you got it right. And we are looking at a monomial here because we only have that 1 term. Now number 4 down here is where we're looking at a quartic again. And this has 2 terms, which would make it a binomial. With number 10, we're looking at a linear again. And we're looking at a monomial. I always forget that I. On number 9, we are looking at a constant because all we have is that number. And we are looking at a monomial again here as well. And then finally, our last one, that's 6n, we are looking at a linear term, or a linear degree, and a monomial term. And if you are not able to print out these notes, make sure that you are writing down all this information that's up here in this chart. And you're also writing down the problem number and all the information that is given to you so that you know where you are getting these from. Because this is your practice for what's going to be on your test. All right, so now we are going to look at adding and subtracting polynomials. And our objective here is that we'll be able to add and subtract polynomials. So to add or subtract polynomials, we're combining like terms. Like terms are terms with the same base and exponent. So we're going to add or subtract, and we're going to write our answers in standard form. And that is, remember, when we're going from our highest degree to our lowest degree. Here, let's switch up the colors we're using. We'll go green now. So whenever I'm adding polynomials, what I like to do is just to kind of copy down my my terms exactly as I see them. So we're looking at 3x squared. Let's make this pen a little smaller. So we're looking at 3x squared plus 7 plus x. And then because we have this positive out here, we could distribute it in, but we're just looking at positive 14x cubed plus 2 plus x squared minus x. Now, something that I'd like to do as well is I like to kind of draw boxes or circles around my like terms so that I can visually see what I'm doing. So my highest term here is going to be that 14x cubed. So I'm going to draw a box around it. Actually, I'm going to have my box include my variable that is out front because that is a part of that term. And then so if we go down from cube, we're going to be looking at squared. So I'm going to circle my squared terms. I'm going to draw a line under my x terms. And then this is always the fun part. You got to come up with something creative so you can look at the other ones. I would also draw a line on top of my constants. And I also need an equal sign out here because that is equal to that. So my biggest term that we had was that x cubed. So we're going to rewrite 14x cubed because we're not combining it with anything. Then we're going to look for our x squared. So we have 3x squared plus x squared, which will give us plus 4x squared. Then we had positive x and negative x, which would give us 0x because we have one and we're subtracting one. So we're not going to write anything for our x values. And then we're going to look at our constants. And we had 7 plus 2, and that will give us 9. And this right here is your final answer, what we're equal to. So whenever we come down here and look at number 2, this is where things get a little interesting because of this minus sign, because we have to distribute it into everything that's inside those parentheses. So the first parentheses, I'm going to copy it just like I see it. And then for these, I'm going to change our sign because we're multiplying it by a -1. So we're looking at negative 3x squared minus 2x plus 5. And I'm going to do my same thing again where I either circle, box, do lines underneath. And my highest degree here is at x squared. So I'm going to make sure that I get my negative inside my boxes with me. So I know whenever I'm combining like terms, I won't forget them. Then I have my positive, my x, and I'm going to underline my constants. So we have negative x squared plus negative 3x squared. So that is going to give us negative 4x squared. Then minus 2x is next. And then 5 plus 1 gives me 6. And don't forget, we are writing these in our standard form. So we're writing with our exponents in descending order. So from our highest to our lowest. And that's just another reason I kind of do the boxes and I go from that highest to that lowest to make sure that I'm already in standard form. All right, so I'm going to let y'all practice with these. So go ahead and try to solve number 3 and then input your answer. Once you input your answer, I'm going to go over it with you so you know what you're looking at. So I'm going to write down that first parentheses exactly as I see it. So negative 36x squared plus 6x minus 11. And then since we have this positive, I'm just going to keep going. So plus 6x squared plus 16x cubed minus 5. So if I'm glancing at all my exponents here, that plus 16x cubed is my biggest one. So I'm going to go ahead and square that in. And then my next one is going to be that x squared. So I'm going to circle those with our sign out front. That one kind of was covering my 11. So I'm going to go back and recircle it. And I'm going to underline my just x to the first. And I'm going to put a line on top of my constants so I don't forget about them as well. And you could also take even a highlighter if you have several different highlighters or colored pencils or something like that, and just color over that specific one that you were wanting to look at. This highlighter is huge. We're going to take it down a notch too. With orange for our x's. It's my only x. And then we'll do like a baby pink for my constants. So you can do that if you need to. You can color coordinate them, or you can write it with colored pen whenever you're copying them down. So something similar to that. But so if we're looking at our x cubed is our highest power, so we're going to go ahead and bring down that 16x cubed. Then we're looking at negative 36x plus 6, and that'll give us negative 30x squared. You can type that in a calculator if you need to. I know kind of the bigger numbers kind of scare some people. Then our next power was that plus 6x because we don't have to combine it with anything. And then we had negative 11 and negative 5. So if we have negative 11 plus negative 5, we're going to get negative 16. And that would be our final answer here. All right, so let's go ahead and look at number 4. And if we're looking at this one, so don't forget, I'm going to give you a little bit of reminder before you go ahead and do this on your own, that negative out here. So we're going to have to distribute that negative in. But I'm going to give you a second to go ahead and solve this yourself. And we'll go from there. All right, so I'm going to copy that first one down exactly as I see it. I'm going to make sure that actually looks like a cube. Plus 12 plus 6x squared. So then remember when we get here, you have that negative. So we're going to have minus 15x squared minus 3x plus 2. So you can either think of it as distributing that negative in, or you can think of it as changing the signs that's in front of your numbers. So I'm going to continue to circle. If you want to use colors, you can. My highest degree is that x cubed. Then we're looking at squares. And then we're looking at our x to the first, and then our constants. So 5x cubed was our only cube. For our squared, we have positive 16 and minus 15. So that will end up giving us negative 9x squared, I believe. Yes, negative 9x squared. And our minus 3x, and then positive 12 plus 2 will give us 14. And that will be your final answer there. All right, so as you can see, the next page in our notes is a bunch of problems, 10 to be exact, where it just says add or subtract and write your answers in standard form. So today we are actually going to skip over that page. We are going to come back to it the next time I see y'all. And for example, for distance learners, I will put a video into Play Pause It. You will be practicing on these on your own. I'm not going to do them for you. So while you're practicing them on your own, whenever you get your answer, you are going to type in your answer on Play Pause It, and then I will go over the answer with you and make sure that you are solving it correctly. I just want to check and make sure that y'all are understanding where we are going with this and your understanding of your combining of like terms. All right, so we're going to skip this one for now. And we are going to look at multiplying binomials. And our objective here is that we will be able to multiply two binomials. So when we are multiplying polynomials, or in this case binomials, we multiply each term in the first factor by each term in the other factor. Then we combine our like terms. My preferred method of this is the box method because box will work for any kind of polynomial. However, there is another method called FOIL, and it's first, outer, inner, last, which only works when you're doing binomials. And then I say in here, if the box method doesn't work for you, we will discuss FOIL at another time. I'm actually going to do FOIL on two of these and the box method on two of these so that you can see both of them and you can choose your preferred method of doing it. You will get the same answer either way. Actually, you know what? We're going to do the FOIL and the box for the first one together, and then I'll do FOIL for one of them, box for one of them, and then maybe we'll do FOIL and box again for the last one. But so for the first one, and we'll do the box method first for this one. So whenever you're doing the box method, you are going to draw a box. So which in this box needs to be a little bit bigger. And you're then going to want to split your box up into 4 different pieces because you are then going to write each term on the outside of a box. So if we were looking at this specific one, so we would be you're then multiplying what's on the outside of your box. So we would be multiplying 5 times 7 and get 35, and x times x, which would give us x squared. Then we're doing that 5x times 2x, which would give us 10x, 1x times 7x, and then 1 times 2. And then you would just pretty much combine like terms and remove pieces from your box, if that makes sense. So this would end up equaling, here, we'll write it up here at the top. So this would equal 35, not 3x. This would equal 35x squared. We have to add the terms that are across because it'd be 10x plus 7x, which would give us 17x plus 2. And that would be our final answer here. So if we were looking at FOIL, which I'm going to rewrite this down here below this, and if we're looking at 7x plus 2 and 5x plus 1. So remember, we were talking about first. So this is where you're multiplying your first term by your first term. So you'd be doing 7x times 5x squared, which we've already said was 35x squared. And then you are doing your outer. So you would be doing your 7x times your 1x, because those are your outer terms, which you would end up with plus 7x. Then you would do your inner, which would be that 2 times 5x, which would give us 10x. And then finally, you would do your last, so 2 times 1, which would give us positive 2. So then at that point, you would combine like terms, and you would have 35x squared. You would have positive 7x plus 10x would give us 17x plus 2. So if we look up here, we get the same terms, or the same final answer both ways. We just went through a different method to get it. So, and the way that I kind of grew up doing FOIL as well was that, I'll do this in the green one. Take your first term times the first term in your second one times your second term in your second one. Then you take your second term of your first one and multiply it by the first one, multiply it by the second one. So you just got to make sure that you have an arrow, 2 arrows going from this first term to each term in your next one, and then 2 arrows going from this term to both in your next one as well. So you can kind of choose your favorite here and kind of go from there. So on this number 2, let's do the box method so that y'all can see it whenever we're looking at negative terms in there. So I'm going to go ahead and draw my box. I'm looking at x and -1. So you got to make sure that you bring those signs with it if there's a negative out in front of it. So then we'll look at x and -7. So x times x is x squared. X times -1 is -x. -7 times x is -7x. And -7 times -1 is going to give us +7. You don't have to write the positive in there. You can if you want to. doesn't really make a difference as long as you can recognize that's positive 7. So then we know that our final answer is going to be x squared. We got to combine the like terms that are across from each other, or diagonal from each other, I guess would be a better word. So negative 7x plus negative x would give us negative 8x, and then plus 7. And that would be our final answer there for number 2. All right, so if we were then to FOIL number 3, which I'm going to copy it down here so that y'all can see it a little bit better. So we would do first times first, which we would get x squared. Our outer terms, so we'd be looking at x times positive 5, so positive 5x. Then we're looking at the inner terms, negative 3x. And then our last terms, which would give us negative 15. So then we have to go ahead and make that last step of combining like terms. And we are looking at x squared plus 2x minus 15. And I got that plus 2x from that 5x and that negative 3x. And then finally, we're looking at number 4. We can do this one. We'll do this one both ways again so that y'all can see them. And you can kind of just pick your favorite because we're still looking at a binomial times a binomial here. We can still do this. So let's go ahead and draw our box. Go ahead and split that box up. So the reason that we're doing 4 total boxes on the inside is because we're doing a binomial times a binomial. If we were doing a trinomial times a binomial, we would just add on another box, which I'll show y'all on the next one. So we're looking at x squared plus 2 and x plus 11. So this will end up being x cubed. This will be 2x, 11x squared, and 11 times 2 would give us 22. So our final answer here, once we combine to like terms, my pen went out again. Sorry about this, guys. Hang on one second. My pen that I use on this computer all the time loves to go out on me. I think it's its favorite part of its job. It doesn't like to work. All right, there we go. So we're looking at, once we combine like terms, we're looking at x cubed. So this time we have 11x squared and plus 2x. So we are not going to combine those terms. We have to take them as they are. So x squared plus 11, x cubed plus 11x squared plus 2x plus 22. So and then if we were to get down here and FOIL that one, we're looking at x squared plus 2, x plus 11. So again, the first times first, give us x cubed. What was it? First outer. So our outer terms is that x squared times 11, so plus 11x squared. Then our inner plus 2x, and then our last terms would give us 22. And if you're a little bit confused on where I'm getting that first, outer, and inner, and last, is because that's what FOIL stands for. So the F is for first, O is for outer, I is for inner, and L is for last. So that is where I'm getting all that from as well. So, and then again, the next page of these notes is a bunch of practice problems that we're going to do the next time I see y'all. So we're going to go and hold off on those and we'll go over them next time. But so now we're going to talk about multiplying polynomials just in general. So our objective is to multiply 2 polynomials. So it's not just binomials. It could be a monomial, a trinomial, a polynomial with 5 terms. Like it could be kind of anything here. So similar to what we did, which this says yesterday, because these are notes from last year whenever we were on 7 periods a day. So with binomials, similar to what we did yesterday with binomials, we can multiply polynomials. We will still use the box method, but tweak it for the problems we are given, or just use the distributive property. So an example of like when we can just use the distributive property is number 1. But on number 3 and 4, we're not going to be able to just use that distributive property. It just gets very complicated, and for these, I'm just going to be doing either distributing like we can in 1 and 2, or I'm going to do the box method for 3 or 4. And this is why I like the box method, is because we can use it for everything. It's not just that we have to FOIL. FOIL is something y'all need to see, but y'all can use the box method. So for example, if we are looking at number 1 here, let's go with orange. We haven't used orange at all today. So we can distribute our 6v into here. So 6v times 2v would give us 12v squared. And then 6v times 3 would give us 9v. And that would be our final answer. So with that one, it's just as easy as just distributing in that 6v. And then I'm going to let y'all do number 2. I think y'all got this. It's very simple. You're just going to distribute in that 2x. So hopefully you did 2x times negative 2x, which would give us negative 4x squared. And then 2x times negative 3 would give us negative 6x. And that would be your final answer there. And for example, I'll show you, if you wanted to do the box method for these, you could. So you'd be looking at 6v, which would be multiplying it times a binomial. So 6v times 2v would give us 12v squared, and 6v would give us 9v, which would end up being 12v squared plus 9v. So you can do the box method for these if you would like. It's just kind of easier just to look at it and distribute though. All right, so for these down here, though, we are going to be doing the box method. We're going to put 2 on top and 3 down the side. So 1, 2, 3. So the 2 on top is going to be that 4a, and that 2, then 6a squared, negative a, and positive 2. So if we are looking at that first top left box, we're looking at 6 times 4 for our numbers. So we're looking at 24, and then a cubed because we have a squared times a. And then over here, we're looking at 12a squared. This will be negative 4a squared, negative 2a, 8a, and 4. So, and the nice thing here is that these two are squared and these are a. So you got to remember to combine those like terms for whenever we're writing our final answer. So we're looking at 24a cubed. And then 12a minus 4a is going to give us 8a. So plus 8a squared. I'm going to go down, but you'll be writing this all across. And then 8a minus 2a would give us plus 6a and then plus 4. So your final answer here would be that 24a cubed plus 8a squared plus 6a plus 4. Because remember, we are writing these in standard form, and we are going to write them from that highest degree to our lowest degree. And then finally, our last one over here, we're going to do a similar fashion. That is way too small to be a box that we're going to need. So we're going to draw our line down and then our 2 lines across. I'll put 7k. Oh, my pen's going out again, guys. And I know it works because I have batteries in it. Oh, it's just in a mood tonight. So we're looking at 7k, negative 3. And then over here, we're looking at k squared, negative 2k, and 7. So 7k times k squared is going to give us 7k cubed. K squared times negative 3 is negative k squared. Negative 2k times 7k is going to be negative 14k squared. This will be positive 6k because negative 3 times negative 2 is positive 6, and then our k. 7 times 7 is going to give us 49k, and then 7 times negative 3 is going to give us negative 21. So then again, we got to combine our like terms, which is kind of nice because they're diagonal from each other. I'm going to see if I can get it all up here this time. So we're looking at 7k cubed. Then we're looking at that. It was negative 3 and negative 14. So that is going to give us negative 17k squared. And then we were looking at 49k and 6k, giving us plus 55k minus that 21. So I almost got it to fit. And that'll be your final answer there. So and then again, that whole next page is some practice problems. And then there's a random page that I couldn't get rid of, but here we are. So y'all's homework is also going to be posted onto my plan book. So the PDFs that are going to be linked at the top are these notes and then also your homework. So make sure that you check both of those out. I'm going to have y'all get a little bit of practice in, especially about the naming each polynomial by degree and by terms, and then a little bit of practice pretty much with combining like terms so that I know that y'all are good for the practice with the multiplication that we're going to be doing next class. So make sure you get that homework done and submit it into Seesaw. And you'll have a good rest of your day, and for my A-Day kids, tomorrow, that is Tuesday, where the seniors are taking the ACT. That's a very, very good day to get caught up on some missing work or some mathia. If y'all got questions, email me so I can help you find your assignments, all right? Other than that, y'all have a good rest.